I'm going to go through calculating the log returns for the same series of SPY prices. SPY is an index fund related to the S&P 500. I'm going to start with the file prices1 where we had calculated the multiplicative returns. And so if you have Jupyter Notebook open, what we could do is we could copy this prices1 file by going up to File and making a copy. And notice it brings it up on a separate tab as prices1 copy 1. I'd rather rename that, so I'll go up to File again and rename, and I'll just call this prices2. Okay, so we have the same information here. We can rerun these other cells and be sure that we're still getting the SPY prices. Now, what we're going to do is just adjust this and calculate the log returns. This is optional, but we'll go ahead and change this description and formula. So we're going to calculate the log returns. And to run that, I hit Shift-Enter, but you can also do Run. And then this will look a little bit complicated, but and again, it's optional, but I would like to have the right formula here. So it comes up in this code that's called LaTeX code. And what we want is not the fraction of the stock prices, but the natural log of the stock prices. And I'd like to have, we'll put this fraction in parentheses. And the way we do that is do left, and then a parenthesis, and then right, and then a close parenthesis. And then I can go ahead and run that. And that shows the calculation that gives us the log returns. We need to change this formula as well if we want this to be correct. If R is the log returns, then the current price is calculated from the previous price as 1 plus the log return. Now again, this is just a description. There's no calculation here, but it's helpful to reference that. All right, so instead of the multiplicative return, in this file, we'll calculate the log return. And so all I'm really doing here is just changing this description. And then here is the ratio of the current stock price to the previous. But we want to put in the function here in Python that calculates that. And the function is np.log, and then I've got a parenthesis here and a close parenthesis. So if we run this cell now, these returns should become the log returns. And now you'll notice there's some negative returns. If the stock price, say, decreased from one day to the next, you've got a negative about 1.5% return for that month. Now, if we wanted to plot the log returns, we could do that. We'll notice that they kind of are centered more around 0 now. More of them are positive than negative, but there certainly were some large monthly negative returns. Okay. We can just look at the header. We'd like to drop the first one. We can do that again. The header, again, is just the first 5 rows. Now, we could re-export this to Excel, but I'm going to go and use Python to calculate some statistics. So let's insert some cells. The way you can do that is do insert cell, and I'll insert 3 to start with. Okay. And we're going to calculate the statistics or the log returns. And this is just a descriptive cell. And up here, that's in the cell type, if you want to have a text cell like these up here, then you would change this to what's called a markdown cell. And now you can run it, and it'll give us a description. So we'll calculate the mean, and our data frame is called SPY. We have a field called log return, and so we'll calculate the mean of the log return. Now, if you run this, you'll notice I'm saving this into a variable called mean. If I run this once, it's going to look like nothing's happened, but it has calculated the mean. If we want to see that mean, what we can do is rerun it and just tell it to output the number. And so now we see the monthly mean. And then let's do the standard deviation. You can call it, again, this is just a variable. You can call this variable whatever you would like. STD is the calculation for standard deviation. I'll put it again on the second row just so we get to see the result. So those are the mean and standard deviation of the monthly returns. Now let's calculate the geometric Brownian motion GBM parameters. I'll insert 3 more cells. This will just be a description. I'll make that a markdown cell. So for mu hat, the formula is that this is the mean divided by delta plus the standard deviation squared divided by 2 times delta. And one thing I'll have to do here, the notation in Python for an exponent is the double asterisk. I first put the caret, which is the Excel symbol, which won't be quite right. Now, one thing I didn't do, I need to define this delta. So let me, before I run this mu hat, I'll insert 1 more row and just define delta. And it's 1/12. Okay, it's 1/12 because we extracted from Python monthly data. So now this delta will have a meaning, a number, and it's 1/12. So this is the formula for mu hat. And what it really is an estimate of the annual return on that SPY. And so you could equate this with about 8.7%. Now we'll do sigma hat. And the formula for sigma hat is that it's the standard deviation divided by the square root of delta. Now, there are other ways to calculate the square root in Python, but this works because the square root is an exponent, and then the 0.5 or 1/2 power is also the square root. You can find other ways to calculate the square root or functions as well. But that's our sigma hat. We could extract these to Excel. For right now, I'm just going to copy these numbers into Excel and then do the simulation for the geometric Brownian motion.